This is the remains of my attempt at an autonomous off-road cooler. Now this episode was inspired by one of our producers who's an ultrarunner. He wanted a device that would follow him around with snacks and drinks over whatever terrain he chose to run. This is an adaptation of an RC crawler. And on the front here, we've got a live video feed, we've got GPS, and we've got a whole lot of other mechanical bits and bobs that have to work together to make this thing work. Now, I found out this was a very difficult project. For this to be considered a success, I had a few main objectives I wanted to hit. Number one, I wanted our cooler to have an autonomous mode, and a mode that lets me pilot it remotely. I wanted it to be capable enough for off-road terrain, but also fast. And I wanted it to be powerful enough to carry hydration supplies, as well as ice to keep those supplies cold. And finally, it'll need to successfully complete a trail run with me, along with a series of support missions I'll be putting it through. But before that, we needed to get this built. One of the hardest parts about this entire project has just been learning how to use the software known as ArduPilot, which interfaces with a flight controller and a GPS module to drive the RC car autonomously. There are a lot of parts here. Never fear, thanks to YouTube, I know that all these components need to look like that. Oh my God, got the connection wirelessly. Look at this. I move this and stuff moves on the screen. Whoa. This is so cool. So I've got a wireless connection between that little thing in the middle of my driveway, the flight controller setup, and my MacBook here. Obviously, it's not actually moving around. It's just in some tall trees, so a bit hard for the GPS to connect. However, I do have a location. I have a wireless connection here, and if I take it for a walk down my street, I should be able to see the track on the map here on screen. Oh yeah, there it is. Sick. I walk down one side of the street and back the other. Heck yeah, that's cool. Okay, another major milestone. The buttons and switches on this radio here are controlling things on the screen of my computer. I feel so smart right now.
Internal error, arm check. Internal errors 0x 3000 liters 1200.
That feeling was short-lived, and it was time for some more programming. So at this point in the build, we've managed to get this flight control board to successfully send inputs to the speed controller for the car, the steering servo, and this servo which shifts the 2-speed transmission. The flight controller is also taking input from the GPS module, and it sort of drives a route that I programmed, sort of. It also successfully takes input from the RC radio so I can drive it manually, and it communicates with my computer via this little radio link here, so all that's a pretty good success. I think at this point it's time to carry on with the physical components of this build, actually locating all these in a safe place on the car, attaching the cooler to the top, which is like the whole point of this, and I've got a few other surprises along the way. Yep, I'm liking that. And then we're gonna have some cross pieces here. Oh yeah. I think we need some uprights here in the back and in the front to support our frame. Okay, there's our fronts. Oh, look at that. Okay, just finished mounting everything up, and field producer Claire is here with the final pieces.
Yeah. I feel like with the googly eyes, it kind of needs a name.
Oh yeah, Chase. Its name is Chase.
Ah, Chase. Excellent.
It's like it's either going to be chasing you or we're going to be chasing it.
Love it.
With the build complete, it was time to put Chase's self-driving skills to the test. Okay, so we're here at the park because Chase's software is able to learn a little bit about the vehicle as it drives around. So we're gonna give it a couple laps to kind of learn the new weight of the whole vehicle, learn how to turn, and learn how to manage its speed over a few different types of terrain before we try to program in our running route. Okay, so Chase has a GPS lock. You can see here on the map. We are standing here under this building here, and Chase is right out there. And we're gonna go and give Chase a little route to do, fully loaded with snacks. So I'm just going to click around here and add some waypoints. Then we're gonna arm.
System 1 is armed.
Ooh. And then we're gonna go to auto mode.
Mode change to auto for system 1.
Oh, and there goes Chase. Starting right off with a little turn in the wrong direction, but Chase is correcting, overcorrecting a little bit. I'm gonna keep my finger on the disarm button.
Chase is not stopping.
Chase is not going the right direction.
Chase is going to the water.
Chase, that's the wrong way. Where are you going? Okay,
System 1 is disarmed.
What happened?
I don't know. Chase avoided the entire flight plan and then just went and did his own thing. So I'm gonna drive Chase around manually a little bit and kind of get the compass to calibrate. Oh, that lean is something.
Mode change to auto for System 1.
Yeah, Chase. Chase, you're flying.
We are beelining again.
MAV001 reached waypoint 1. MAV001 reached waypoint 2.
Oh, hell yeah. Is it gonna stop?
Yes!
Oh!
Crushed it!
And
Worthy of celebration.
it's not overflowing. It's a little shaken up, but
It's okay. That's what you want.
oh, that's great.
Yes, good job.
So Chase missed each of the waypoints by about 10 feet. We're gonna
Kind of a lot.
So we're gonna do some more laps and try to let Chase calibrate himself. Basically, it's learned now which direction it's facing and it's trying to go to each point, but like since it's heavier, it takes more power to turn the wheels. So it's missing each waypoint because it hasn't learned the parameters of the vehicle yet.
Gotcha.
Yeah, it actually almost hit the last waypoint and that was only 5. So that's pretty good.
Okay.
I drove Chase around manually a little bit to help him learn the terrain. Then it was back to sending him out on his own.
No, where are you going? Back to the water?
Are you doing this?
No, I'm not doing this.
What?
It's going the right direction. Oh, now he's not. Not at all.
Whoa, whoa.
Whoa, Chase! Disarm. Chase, what is happening? It's going right for the bush.
Oh no.
Oh my God.
Going a different direction.
Where are you going?
Oh no. Oh no. Back at it.
I have a theory. On the first successful lap, we had 4 beers in the cooler. Then we celebrated by drinking 2 beers, leaving only 2 beers left in the cooler.
Ooh.
And it stopped working. So I'm thinking these aluminum cans are affecting the magnetic field.
Whoa, not the weight.
Oh, maybe it's the weight. I'm thinking too hard. Or it could be the fact that the flight control board is just rattling around here because the double-sided tape came undone. Could be that. But I'm thinking it's the magnetic field of the beers.
Okay, let's see. And we're off. Oh, we're getting wobbly.
This is not the flight plan. It's just freestyling. Uh-oh.
Oh, into the logs again.
System 1 is disarmed.
What are you thinking?
I don't know. I'm just thinking is all. Trying to figure out what could be. Look at that. He's so zen. Is he meditating right now? So Chase has gotten some extensions. We've moved the electronics from the front here, which is really close to the speed controller and the big motor and these aluminum rails and the steel parts of the chassis. We've moved them up to the top of the cooler here, which should give it some better elevation off the ground so the GPS module can pick up its signal easier, and it should keep the compass away from the metal and the other electronic interference that we've been having. So hopefully we have some better luck now with this guy following its waypoints successfully. Okay, first attempt with the new configuration. Come on, Chase. Come on, Chase.
MAV001 reached waypoint 1.
Turn right, turn right, turn right. Oh my God.
MAV001 reached waypoint 2. MAV001 reached waypoint 3.
Killing it so far.
Oh my gosh.
MAV001 reached waypoint 4.
He's dead center. Chase is killing it right now.
MAV001 reached waypoint 5.
Oh, that's a sharp turn.
Oh!
Barely dodged the deck.
Whoa! That was incredible.
Did he just hit all of those?
He hit them all.
Oh my gosh.
So I think I'm gonna put my Insta360 camera on there, get some onboard footage,
Perfect.
and try a couple more missions before we take it back and try it on roads and trails. I think we're getting close. Here
Mode
goes.
change to auto for System 1.
There he goes. He's off.
Jogging on the trail. Chasing, chase. Oh, he corrected. Oh, we're going so fast. We're going so fast. Oh. Oh, save. Steer down. Oh my gosh. Somewhere off into the bush. Is this right? Is this where we want to go?
Look at that. What a creative little robot we have.
Chase certainly didn't take a direct route, but he did hit all the waypoints, eventually.
We're taking a giant leap here, filled with confidence after a success at the park. I'm gonna try to have Chase the cooler filled with my running snacks. Follow me on a run. On the map here, I've got my running route planned out. And if all goes well, Chase will follow me out the driveway, take a left, and then come back.
Change to auto for system.
Let's go. We're off to a rough start, but that's typical for Chase.
Change to auto for system.
Here we go. Here we go.
Wrong way. Where are you going?
Yeah. Here we go.
That first car, that first car.
Jeez. Okay. The compass.
Freaking way. Oh my God. Come on, Chase. Got it. Where are you going?
The compass.
My God, Chase.
Oh no, did that break?
Oh no. Snap my antenna off.
Not ideal.
Not ideal. Gotta run in. Got my heart rate up. I was, like running fast and also scared because of potential property damage. And now I broke the antenna off. Well, it kind of broke it up itself. Okay, still got some work to do.
Okay, so after days of trying to get the programming right and dealing with faulty compasses and GPS chips, we've come up with a new way to use our system. Instead of having a robot drive itself, you just grab your training partner, put on these cool looking VR goggles, and you get to sit at home with a drink in hand and just follow along via live video feed while your hardworking training partner goes out on a run. At the same time, I'm also the first human to ever get to take a robot's job. And just like that, my hardworking training partner had all the supplies they needed, right on demand. And neither of us had to carry anything. At this point, we thought we'd take our ideas that sort of worked and just make them go really, really fast. Oh my God. So in a somewhat obvious conclusion, making a self-driving vehicle that's off-road and high-speed capable, it's a pretty big challenge, especially using hobby-grade GPS components. Now I did consider the possibility of using something like a Bluetooth fob that the runner or rider could carry with them and have the vehicle follow them. However, I don't think it would have made the project much easier. I think the vehicle knew where it needed to go because it was showing up accurately on the GPS map. A big part of the challenge was just getting the flight controller to drive the vehicle accurately, especially when you change the payload or the speed. And then of course, if you went in the trees and the GPS signal dropped a bit, everything would go haywire. So as you may have guessed, making a self-driving vehicle is difficult. That's why we have LiDAR and vision systems and AI and teams of engineers working on this problem. That's still a challenge to this day. I have newfound respect for those food delivery robots, even though I'm still very suspicious of them. And now that I'm a bit more experienced with this hardware, I would love to take a deeper dive into this project once I learn a bit more about the programming side of things.